Given the graph, state the degree of the polynomial function and the sign of the coefficient a. So we want to highlight the things that are important for us here. We want to find the degree, and we want to find the leading sign. If we look at the first graph, we notice that our end behavior in this case is running from Q2 to Q1. So we've got end behavior up here, and we end up over there. So this tells us that our degree must be even and that we must have a positive leading sign. So that's the only situation that fits having end behavior of this kind. If we also look at the graph itself, remember if we're driving along this road, we'd have to turn our steering wheel to the left once, back to the right a bit, and then back left again to stay on. So we've got 3 turning points. And in this case, with 3 turning points, we know that the degree of our function is often 1 higher than the number of turning points, or the same as the number of x-intercepts. In this case, we've got a point of inflection here, which means there are 3 x-intercepts right at this point, and we have a single passing through x-intercept over there. So we're pretty confident to conclude that this is a degree 4 function with a positive leading sign. If we look at our answer there, that makes sense too. If we now look at our next graph over here, in this case, we've got end behavior that runs from Q2 and ends down in Q4. This tells us that it must be an odd degree function, and on top of that, we also have a negative leading sign. If we go look at the graph in more detail, number of turns, we've got 1 turn over here, a 2nd turn, a 3rd turn to the left, and a 4th turn to the right. So we've got 4 turning points telling us that this is most likely a degree 5 function with a negative leading sign. If we look at the answer, that's what we end up getting as well.